Here we go. All right, so we are in record mode now. Again, everything that you guys need is out in the Canvas course. Okay, so here's that course that you're all connected to. So today's session in college algebra, this is over the final that you guys will be taking next week. All that material will be put up into here once everything is done. So this is the version that we're working with today. The answer guide will be coming along with what we do today. So after we're done today, that solution guide will be sent to Deanna. And then the video we're making right now. So that will be uploaded as well later on. So here's where you'll access all that information. Again, if you need it after today. Okay. So here we go. Your final is accumulative. I'm going to do my best to remember where everything came from because I know in college algebra we kind of jumped around from sections to sections. So you can see that this is multiple choice. I believe the final exam is also multiple choice when you take it. So we're definitely comparing apples to apples here. So this first question, complete the square, is coming from section 1.2. Coming from section 1.2. Okay?
Okay.
So from here, I'm just reaching in to grab my college algebra book. It says complete the square on this. So I'm going to show you complete the square, but again, if your professor is not having you really submit work or anything like that, you just got to answer stuff. This is a quadratic. You know lots of ways to solve quadratics. You can use a graphing calculator, although since these are exact answers, it's not going to help you very much. You can try factoring. You can do the quadratic formula because the quadratic formula works 100% every time. You can complete the square. Okay, so I'm going to remind you on how to complete the square, but if your professor's not looking for any work, you could have easily run the quadratic formula on this, and we would never know. So I have our problem written down. So let's talk about complete the square.
I can't see it.
Can't see it. Oh, shoot. My desktop was paused the whole time. I apologize for that.
No worries.
So here's that number that we were talking about, number 1. So x squared plus 4x minus 7 equal to 0. They want us to do complete the square. And from there, okay, as I said, there is no way that we would know whether you did it one way or another. So complete the square. The first thing you got to do is you got to find a C value that's going to make this part factorable. Okay? And complete the square, we want to make this factorable. So we're going to find a C value. And to find that C value, you're going to take B divided by 2 squared. So our B value up here is 4. So 4 divided by 2 squared. Well, 4 divided by 2 is 2. We're going to square that, and that gives us 4. Okay? Mm-hmm. So this is the number that's going to make this thing factorable. All right, now, we're going to take this guy, and we're going to start turning this into a quadratic that is factorable. In order to turn this into a quadratic that is factorable, we need to move this -7 to the other side. So how do I get rid of a -7?
Add 7.
You got it. So x squared plus 4x is equal to 7. Now, here's where we're going to use this number that we found. And again, I show a lot of work up here because later on, this number 2 is going to become important for us. So that's why I show all this work, even though I could have done this in my head. 4 divided by 2 is 2, 2 squared is 4. I show this work all for a reason. So right now we're going to deal with what the actual C value is. And what you're going to do is we're going to add that to both sides.
Okay.
So we're going to have x squared plus 4x plus 4. I added that number. And on the other side, I'm going to have 7 plus 4.
Okay.
See, I added it to both sides. That's our number. We took this guy and we added it because it keeps it balanced. Remember, an equation has to stay balanced. So this side right here is now factorable. And if you wanted to, you can factor it, but you don't have to. Because I'm going to show you a fast way that this thing factors. So right over here, all we're going to do is put like terms together. 7 plus 4 is 11.
11.
And this side right here is going to factor into a parenthesis squared. And so inside here, you're going to have x. And then we're going to look at this number that's right here. Remember, I said this number was important to us. So now we're coming back to it. This number tells you what's going to go right here. And since it is a positive 2, we're going to put plus 2. If that was a negative 2, I would have put minus 2. So whatever this number is before you square it, that's how this thing factors in here. It goes right in that parenthesis right there. Okay?
Okay. Mm-hmm.
So this little square kind of matching up my notations that I kind of put around there. And then now that's to complete the square part. All we got to do now is solve for the x. So how do I get rid of something squared?
Square root.
Okay. So we're going to square root both sides. So the square root takes care of the square, and that gives us x plus 2 equal to, now what do we get over here?
It just stays there that way, right?
Just stays that way. So it's just the square root of 11.
Yeah.
No.
No.
Missing something. This is
Minus.
always what I've been harping on you guys.
Plus or minus.
All plus or minus. Anytime you take a square root of both sides,
Right.
you have to have plus or minus.
Got it.
And then last but not least, how do we get x by itself? How do I get rid of a plus 2?
Subtract 2.
Subtract 2. And again, these two are not going to get together because the only way that you can put radicals and numbers together is if they are the same radical. And this one doesn't even have a radical. So x is equal to negative 2 plus or minus square root of 11.
Plus or minus.
Because again, these two are not getting together. So if we go back to our document, well, it's not that guy because it only has plus. Here's a negative 2. Here's a negative 2. We've got a plus square root of 11. We got a minus. It's got to be B.
Yep. B.
Okay.
Mm-hmm.
B is our answer. Everyone good so far? I know that there's some chats going on. Deanna, is everything okay in the chat?
Yes, everything is good.
Cool.
And I think we lost Kathy. Maybe she was in the wrong session. She asked me if it was intermediate algebra.
Oh, wow. She was where I was. It happens.
Okay. Yeah, that happens. All right. So let's move on to question 2.
All right.
Okay. Question 2 says solve the inequality. So this is coming from 1.6.
1.6.
So we've got absolute value of 3x minus 7, absolute value, minus 7, less than negative 4. Okay.
There we go.
So there's what we got. So what do you know about absolute values? How many answers are there?
2.
There are 2, which means that you're really dealing with 2 inequalities here. Okay? But before I can write those 2 inequalities, what do you have to do?
Get rid of the absolute value.
Nope, not yet.
Oh.
before we can write our two inequalities, what
Um,
has to happen?
oh.
Just kind of prepping
Get
here.
get it equal to 0, maybe?
Nope.
No?
But I like what you're talking about now. I mean, kind of, you know, and there's no equals, just so you know.
Move.
Let's not get it equal to 0.
Dang, I forgot.
Get the absolute value by
Itself.
itself.
So,
You have to do that first.
okay.
So how do I move a -7?
+7.
So this is what you're going to work off of.
Okay.
This is where our answers are going to come from. And -4 plus 7 is 3. Okay, so this is what you have to work off. You cannot do any equation writing until that absolute value is by itself. And since this is an inequality, remember in absolute value inequalities, you're going to be dealing with ands and ors situations.
Okay.
And or situations. All right. So how do we write the first absolute value inequality? How do we take this and turn it into the inequality we need to solve? What are we going to do? This is usually the one that we all get correct. It's the second one that we generally kind of have trouble with.
I know we changed the signs on the second one, but I forgot how we.
Not for, yeah, for the second inequality, we're going to do some sign changing. But what do we do for the first one? What do we got to do to set up this inequality?
Do we. Dang it. Do we equal it to 0?
No equal to 0 on this.
Dang.
Because you can't, remember, if we wanted to equal to 0, we should have just did that from the beginning.
Right.
You talked about it earlier, and I said, not yet.
Mhm.
Drop.
Drop the absolute value. Yeah, I knew
Yep.
that. I thought
That's
there was a
it.
trick to it.
Nope.
Okay.
All you're going to do is drop the absolute value.
Okay.
3x minus 7 less than 3. That's our first inequality. Now,
Okay.
what do we do to get the second one?
I know we changed all the signs.
All the signs where?
Is it the 3? We changed it to a -3? Or?
Yes. All right. So the right side becomes opposites.
Mm-hmm.
So if it was positive, it becomes negative. If it was negative, it becomes positive. What else do we do?
Do we change the sign?
Change. What do you mean change the sign?
Instead of less than, greater than?
Yes. Flip
Flip the sign.
inequality sign.
Mm-hmm.
And what's the first step? There's 3 things you do. Sum, flip, and opposites.
I should know this. I just did on the other math review. Oh, don't you have to move the 7 or no?
Pointing to it, giving you a nice little hint here.
Oh, sorry, I wasn't looking at the screen. Drop that. Well, it's already dropped.
No, you're doing this again. You're not looking at this part.
Oh.
You go back to this.
Drop the absolute value. Oh, okay. I thought it was dropped.
No, you're looking at this guy.
Okay.
You don't look at this one. You
Oh,
look
okay.
at this.
All right.
Okay?
Yeah.
So we're going to drop 3x minus 7. Flip opposite. See, you're working left to right with this.
Right.
Drop, flip, opposite.
Okay.
I always describe it. right, so now we got to do a solve, and then we'll talk about the and the or part.
Okay.
So how are we going to get x by itself?
+7.
Plus 7. So that gives us 3x less than 10. Divide by 3, divide by 3. X is less than, again, they want the fractions. 10 over 3.
Okay.
Okay? Now then we come to this guy. Get the x by itself. So again, you're going to add 7. Gives us 3x greater than 4. Minus, or divide by 3, divide by 3. X is greater than 4/3. Okay?
Okay.
Now, we need to know what kind of situation we're dealing with. Is this an and or an or? And again, it's based off of this. And you're going to look at the sign. So the question is this an and or an or? That's the question we have to figure out now. We've got our answers, but this will tell us how we need to write up our final answer. So is this going to be an and
Oh, sorry.
or an or? So this was our equation.
Right.
Which one is it?
Or.
It is not an or.
Oh.
It will actually be an and.
And.
Remember that when you look at the symbol and how I told you to pronounce these words, that it is less
Than. Yeah. Or greater. Got it.
Yes.
Now I remember.
Great or.
Okay.
Okay?
Mm-hmm.
All right. So this is an and.
Okay.
So that means ands, because we're looking at interval, that's what they want. Interval notation for an and looks like a parenthesis or a bracket.
Right.
And then it's going to be your lowest number,
To your highest.
comma, then it's your highest number and a parenthesis or a bracket. Okay? Or answers, that's the one where you do the union, and it will have the negative infinity to your lowest number, bracket or parenthesis, union, bracket or parenthesis, your highest number onto infinity. So that's an or. That's the one that has the union. Ands are the ones that kind of look like points for a coordinate plane. All right. So let's just fill in. Is it going to be a bracket or parenthesis for our lowest number? Well, which one's our lowest number? That's this guy. Because that's 1.3 repeating. This one over here is 3.3 repeating. So that's how I know this is the lowest number.
Yeah.
So is it a bracket or a parenthesis?
Parenthesis?
Parenthesis, because it's just the greater than sign. There's no equal to.
Right.
So parenthesis, our lowest number, comma, here's our highest number, bracket or parenthesis?
Parenthesis?
Parenthesis, because again, it's not equal to. The only time you put a bracket is if these were equal to's.
Right.
So that right there is our answer.
Got it.
So if we go back and we look, there's only one of these that has the correct one, and that answer is B. Okay?
Mm-hmm.
Right. So that takes care of number 2, and that gets us out of chapter 1. All right. Number 3. Number 3. And if you haven't noticed, our test is pretty much going in order. So we don't do too much of the craziness and stuff like that. So distance, which is what this problem is about. Remember, that was a formula, and that's coming from section 2.1. Okay, so we got this P1, which is equal to 4, comma, -3. And we got this P2, which is equal to 6 comma negative 7. And they want us to find the distance. Okay. What is the distance formula?
Is it the D equals x1 comma y1? Or no, D equals, I think you do the x squared plus the y squared.
There's a giant square root.
Yeah.
I like kind of where you're going, where there's a parenthesis of x1.
And x2 plus or minus x2.
Minus, yeah, you got me putting a plus down. Minus.
Squared.
Minus x2 squared. Yep.
And then
it's a plus.
Plus.
Y1 minus y2 squared.
Y1 minus y2 squared.
You got it. So all we got to do is just plug into our formula. Since this is P1, that means this is x1, y1. If you just take like the 2.5 seconds to write this out, you know exactly where every number is going. Since this is P2, that's x2, y2. So let's plug in. And the biggest thing I see that students do is they drop the absolute value as you're moving through. Don't do that, sillies. So x1 is 4.
4.
Minus, because that's coming from the formula, x2 is 6. And I'm going to square that. Plus, our y1 is negative 3. Minus, because it's coming from the formula, our y2 is negative 7. You need to show the negative 7. This minus is because of the formula. This negative is because of the number. You need both of them. And then it's squared. All right. So D equals, what's 4 minus 6?
Negative 2.
So we got negative 2 squared plus, well, this becomes a plus. So what's negative 3 plus 7?
4.
4 squared. Now, please also, again, another big pitfall. If I square this, I don't care what your calculator says, but this number ends up being positive. Okay? You will never, ever get any negative numbers under this after the squaring. These should be two numbers you add together that are positive. So negative 2 squared is 4. 4 squared is 16. You should have two positive numbers. If you tell me one of these is negative, that means you squared wrong. 4 plus 16 is
20.
20. But you're not done. Because we know how, as we learned from intermediate algebra or any algebra 1, algebra 2 course you had before this in high school, we need to reduce this. So you break it down into its radicals.
Right. Radicals.
The biggest perfect square that divides 20 is 4. 5 times 4 is 20. Square root of 4 is?
2.
2. This is the square root of 5. So there's the distance. All we got to do is just find out which number it is. Let's say.
A.
Yuppers. Okay. So let's jump into question number 4. Question number 4 says, write the standard form of the equation of a circle with a radius r and a center hk. So this right here is coming from 2.4. So this is coming from 2.4. Okay. So they're telling us that the radius is 1 and that the center hk is 0 comma negative 2. Okay, so this is the problem that we have. Remember, this is H, this is K. All right, what is the equation for a circle?
Is it A equals pi times radius squared?
Okay, that's the area of a circle. I
Oh,
like
there.
that. That's more geometry, but we want the equation of a circle.
Oh, equation. I don't remember.
Okay, so it is parenthesis x minus h squared plus parenthesis y minus k squared
Okay.
equal to r squared. All you have to do is plug in the r, the h, and the k and do any squaring. Okay, that's all they want you to do. So if we go in here, this is x minus, what's our h value?
0.
We're going to square that. Plus y minus, what's our k value?
-2.
-2. Squared equal to, what's our r value?
1.
1 squared. All right. What's x minus 0?
0.
0. What? X minus 0?
X.
Yeah, just x. So we're just doing some cleanup now.
Mhm.
So that's really, we would just write it as x squared, although there's really nothing wrong with that. It's fine. But our book likes to, if it's 0 there, it doesn't do anything, just x
Right.
squared.
Mhm.
And what happens with two negatives by each other?
Add.
So this is parenthesis y plus 2 squared. And what's 1 squared?
1.
That's the answer they're looking for.
Oh, okay.
So we just plug in and then just do a little bit of cleanup. That's all it is.
Can
So,
you go back to the page so I can see how they wrote that problem?
oh, yeah. Like what I have here or
The
back
other
in the
page.
document?
Yeah,
Yeah.
when they're asking you to solve it. I just
So
want
here's what it looks like.
Okay, I got it.
So the
So
answer that matches ours is D.
Mhm. Awesome. So far, so good.
I know, right? Not too bad.
Yeah.
All right. Question number 5.
Number 5. Moving along. Is there 30 problems on this?
I believe so, yes.
Okay.
Question number 5, let's see here. The amount of paint to cover the walls of a room varies jointly. Okay, so this is coming from those variation problems from 2.5.
2.5.
All right, so the amount of paint needed to cover the walls of a room varies jointly as the perimeter of the room and the height of the wall. Okay? All right. If a room with a perimeter of 45 feet and 8-foot walls requires 3.6 quarts of paint, find the amount of paint needed to cover the walls of a room with a perimeter of 40 feet and 10-foot walls. All right, so when we talked about this in class, we did this in 3 stages. The first thing I had you do was we need to figure out what K is. Because remember, this idea of jointly, there was an operation with that. When you vary jointly, what did that original operation mean for this? What operation did I tell you to think about with jointly? Because that's the key to this. It's one of 2 operations: adding, subtracting, multiplying, or dividing.
Isn't it adding jointly?
Nope.
No.
Take another guess. Say it again.
Multiplication.
It's multiplication.
Okay. What other
And
words
if
would you
the other word was inversely,
inverse?
and inversely would be division. Now remember how I told you in class that once you find this word, okay,
Mm-hmm.
I want to highlight it.
Yeah, me too.
Okay.
Mhm.
Remember that this word means equals K.
Okay.
And everything that followed before it was in front of the equal sign, any variables, and any variables that followed after this was next to K, representing multiplication. Okay. So we've got this thing that now looks like this. Remember, jointly means multiplication. And that word jointly, I told you it represents equals K. Any variable that is before this or any concept before the word jointly goes in front of the equal sign. Any concept after the word jointly goes after the K.
Okay.
Remember that if it was inversely, anything before the inverse word would be before the equal sign. Anything after the inverse word would have been under K, because inverse meant division. All right, so let's put in our variables. So it says the amount of paint needed to cover the walls. All right, so that's our variable there. What do you want to call it?
P for paint, maybe?
P would be a good variable, but that's actually going to be better for something else. So let's use a different variable. So if we look later on, it says that it's quarts of paint. So what could we use?
Q.
Q. Yeah. Or you could have used A for amount,
Okay.
or W for walls. Something along those. I mean, as long as it's not P, because when you look after the word jointly, it says as the perimeter. And usually we like the variable P to represent perimeter.
Yeah.
So right now our equation looks like this. Quarts is before the equal sign because quarts of paint was talked about before the word jointly.
Okay.
Now, anybody after this word jointly is now after the K. If it was inverse, it would be under the K because of division.
Okay.
All right, so after the word jointly, it says as the perimeter of the room. So that is
P.
P. That's why I wanted to reserve that. P for perimeter. And the height of the wall. What is that?
Plus H.
Nope. I
Oh.
don't see any word that says plus H.
Oh.
It says and. That means there's just two variables. So not plus H,
Multiple.
just H. So it looks like this. Q equals K, and the equal K was the jointly part. P for perimeter and H for height. That's our equation we're working with. Okay? And that's what this first sentence is for, to help you figure out the basic equation. Now we're going to do what I said. We're going to find K. And that's what this second sentence right here is for, before the comma. This part's going to help us figure out what K is, because we can't answer the question without K. So it says, if a room with a perimeter of 45 feet and 8-foot walls requires 3.6 quarts of paint. All right. So perimeter 45 feet. Where's the 45 going to go in?
After the K.
Yeah, for P, right?
P.
So they're telling us that P is 45.
Mm-hmm.
8-foot walls. Where's the 8 going to go in?
With the H.
Because that's the height of our walls. And then requires 3.6 quarts. Where does the 3.6 go in?
Under Q.
So what we have just found out is that our equation now looks like this with numbers plugged in. And again, look, we don't know what K is. That's because we're going to find out what it is. So we're going to take 45 times 8.
360.
360. Okay. So we got 3.6 equal to 360 K.
Mm-hmm.
Then divide by 360. So 3.6 divided by 360 gives us K equal to,
Did I do it right? No, let's see.
what'd you get?
I got, oh, I'm doing it again. 0.01.
Yep. 0.01. So now we're going to rewrite our equation.
Okay.
That's the second step. So this was that first step right there. We got to figure out what K is. Now we're going to rewrite our equation with just K in it. So this is what we're working with now. That's the real equation. This is what we're going to use to answer the final question. Because that's what the rest of this sentence is for after the comma. So right here, in this final piece right here, they give us more information to plug in so we can figure out our answer.
Okay.
So it says, find the amount of paint needed to cover the walls. So we're looking for paint. So that's Q.
Mm-hmm.
To cover the walls of a room with a perimeter of 40. So the 40 is going in for?
P.
P. So we're going to put that in for P. And it says 10-foot walls. The 10 is going in for? H.
H.
That's right. So our equation looks like this. 0.01 times 40 times 10. So all we do is just go to our calculator, multiply all that out. And how many quarts do we need?
Hold on. 100. 4.
4 quarts
Is that right? No?
paint. Nope, it's correct.
Oh, okay.
So when we go back to our problem, the answer is D. So it's really kind of like a 3-step process in here.
I
The
had
first thing, sorry, go on.
No, go ahead. Go ahead.
I mean, it's a 3-step process in here. I mean, you really kind of need to figure out, you know, and this is how I explained it to you guys in class, that you need to figure out your equation kind of first. So figure out that K. Once you got your equation, you needed to use it again. Okay.
Right.
So I kind of put a bullet next to each step. So this was our first piece to find out that K. This is the second piece to get our equation. And then here's the third piece of using it.
Okay. So my question was what you said earlier. I forgot for the inverse.
So if this was inverse,
If it's
it
a
would have
word
been,
problem, then the
you're breaking up, Lorraine, sorry.
I'm sorry. I think I have a bad connection on my Wi-Fi.
Okay. So if it was inverse, the P and the H would have been below the K.
Okay.
Okay. Because the inverse would have been division.
Okay.
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 All right. So let's move on to question number 6. Wrong one. So they want you to do some evaluating. So this is coming from section, checking something real quick. I believe this is 3.1. Yeah, this is coming from 3.1. So they're telling us that we want to figure out what f of x plus h is. So we've got this equation, this function, f of x equal to 2x squared plus 4x plus 4. And we want to know what is f of x plus h. Okay. So what is it that they want us to do with this piece, this x plus h?
Do they want you to put that in? Where,
Yeah. Keep going.
to
Put
keep
it
it,
in.
well, for X?
Yeah. So anywhere we see an X up here, we're putting X plus H.
Okay.
So we're going to have 2 parenthesis X plus H squared, because that used to be X, plus 4 parenthesis X plus H, because that
Oh,
used to be X,
yeah.
plus 4. So all we're going to do now is run some cleanup. So we're going to need to square this. Now, remember, we are not distributing the square through. That is incorrect. What does this square mean about that?
X plus H times X plus H.
That's right. We have 2 of them.
Mhm.
So it's 2 times X plus H times X plus H plus 4 X plus H plus 4. That's what it really looks like when we expand this out. You need to expand this out because we have to FOIL. Okay? So I'm going to go ahead and FOIL this first because I like to deal with the foiling first, and then we'll deal with the 2. So what is X times X?
X squared.
What is X times H?
XH.
What is H times X?
XH or HX.
Yep, both are the same. I just write it as XH. And what is H times H?
H squared.
Okay. Plus, what's 4 times X? Because I'm going to go ahead and
God,
distribute
I'm
this.
losing connection.
It's okay. What is 4 times
4X.
X? 4X. Good. What is
4X.
4 times H?
4H.
Okay. Plus 4. And I'm going to go ahead. I mean, I could do some cleanup in here, like combine like terms, but I'm going to go ahead and just distribute the 2 and then do all combining like terms at the end.
Okay, sounds good.
So 2 times X squared,
2X squared.
2 times XH,
2XH.
2 times XH,
2XH.
and 2 times H squared.
2H squared.
So after all the multiplying is done, that's what it looks like. All we need to do now is combine like terms. So is anybody getting together with the 2x squared?
No.
Nope. So 2x squared. Is anybody getting together with 2xh?
Yes, the other 2XH, so 4XH.
Yeah. So that gives us 4xh. Perfect. Anybody getting together with 2h squared?
No.
Plus 2h squared. Anybody getting together with 4x?
No.
Plus 4x. Anybody getting together with 4h?
No.
Plus 4h. Anybody getting together with 4?
No.
Plus 4.
It's a long equation.
And that's what they want. So we just got to go hunt for that answer on here. So obviously it's not these because there's no XH in them. So it's either A or B. So, and it looks like it's B because that's the one that matches what we wrote.
Oh, God.
No,
Yeah.
just the answer B, not God.
I'm just trying to get a better signal. I keep
I know.
wanting to go out.
Are you all good on number 6, Lorraine?
Yes.
Okay.
Perfect. That one's easy.
No worries. All right, number 7. This one is coming from 2.1 again. Sorry, 3.1. Did I put 2.1 in there? No, 3.1. This is coming from 3.1.
Yeah. Okay.
All right, and it wants you to find the domain of the function. So x over the square root of x minus 1. All right, so if you remember from class, when we find domain, we always assume what in the beginning?
All reals.
That's right. Unless
Right?
we have
All
what?
real?
Yeah. Unless we have what?
Um, a radical
Uh-huh.
or irrational.
You
Or
got it.
irrational.
And if you look at this, we have both of those. This is what I always talk to you guys in class and said, this is that demon love child spawn of the radical and the rational. Okay. So we're going to combine how we find the domain of rationals and radicals together. Do you remember what we do in that situation when we have this demon love child spawn?
Yeah.
Do you remember, Lorraine?
Hold on. I don't, and you were going out. I'm trying to adjust my
Okay.
internet here. I don't remember though.
So, well, when you have a rational, what do you do? Let's just talk about that.
You make it greater or equal to 0.
That's the radical. So radicals get set greater than or equal to 0. What do we do for rationals? Something about
That's
that.
just,
Say it
dang
again.
it. Sorry. You're going out again on me. I'm
So
sorry.
what do we do for rationals?
Equal to 0.
Yeah, who?
The x minus 1.
All right. So we're going to take this x minus 1 that we have here under the radical, and we're going to combine what we just talked about. The denominator is going to get set equal to 0, and the radicals are set greater than or equal to 0. But what we're going to do is we're going to combine those together, and we're just going to set it greater than 0. Because remember, the reason why we set the denominator equal to 0 in a rational is because we don't want the denominator to be 0. And that tells us what number makes the denominator equal to 0 when we set the denominator equal to 0 for rationals. For radicals, we want to be greater than or equal to 0. But again, because this radical is in the denominator, we can't be equal to 0. So that's why we just set it greater than and not greater than or equal to. Okay? Because this is in a rational and the radical's in the denominator, you have to knock off the equal to part. So that's why we take this and set it greater than 0. Anytime you have a radical in the denominator of a rational and you're looking for the domain, take the piece under the radical and set it greater than 0. And all we got to do is solve. So add 1. X is greater than 1. And we like this answer. I believe we have to write it up in, nope, set notation is what they want. So when we're looking at this guy, all you got to do for set notation is put all the embellishments around this. Make your little braces, X, your line, put in the answer, X greater than 1, close it. So that is the answer in set notation. And if we go back, it has to be C. Any questions on number 7? Probably lost Lorraine. All right, we're going to keep moving right along. Number 8 is coming from, just making sure on this, 3.3. So they want to know when the graph is increasing, decreasing, and constant. And constant. Okay. Remember that when you guys are talking about increasing, decreasing, and constants, that you are only concerned with X values. So working along the X axis, you're only concerned with X values and use only parentheses, no brackets. All right, so let's take a look at our picture. So we're going to work from left to right. So my graph starts over here and it's going to keep going this direction. So as we're moving, what's happening to this mouse as we move from left to right? It's increasing. I'm going up. Okay, that's increasing. Okay, or if you're using your finger and sliding along, if your finger starts to go up, that means it's increasing. So when did the increasing start? It started down here at negative infinity. When does the increasing end? Well, I'm going up, I'm going up, I'm going up, I'm going up, going up, going up, going up. All of a sudden I start going back down. All right, so when did this going back down start? It started right here at not 4. That's the Y value. What is the X value? Well, -1, 0. So we are increasing from negative infinity to 0. Don't put 4 there, that's a Y value. We only care about X values. All right, so what's going on the other side? So here, as my cursor comes, it's going down, 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 on towards infinity. So we are now, since we're going down, my cursor went down, my finger, if I followed it, would go down. That's decreasing. So when did this start? It did not start at 4. It started at 0. When does it end? It doesn't. It's going to keep decreasing, 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 decreasing onto infinity. So we are decreasing from 0 to positive infinity. Do we have any constant? And no, a constant is just a straight horizontal line. Even though it looks like this is horizontal there, if you remember from when we were in chapter 5, I believe, that's an asymptote, okay? And you keep getting closer and closer to that horizontal asymptote, but you're not gonna cross it, okay? So it's still going down, although it's going down very, very slowly, okay? So there is no constant. So this is our answer. And when did that happen? Or sorry, not when did that happen? What is our answer here? It looks like it is C, increasing from negative infinity to 0, decreasing from 0 to infinity. So C is the answer. All right. Number 9. So here it wants to determine whether the function is even, odd, or neither. Okay. So this is coming from section 3.3. So we've got f of x equal to -2 x to the 4th minus x squared. So let's talk about testing even. So when you test even and odd, it's just like when you guys did testing for lines of symmetry. Okay? It's just like when you did testing for symmetry, like when you were looking to see if it was symmetrical to the x-axis, symmetrical to the y-axis, symmetrical to the origin. So when a function is even, that means that it is symmetrical to the y-axis. Okay? So if you are symmetrical to the y-axis, that means all you need to do is plug in a negative x and see if it kicks out the same equation. Okay? So we want to plug in a negative x and see if we get the original equation back out. Okay? If this is true, then it's even. So we got -2, parenthesis, negative x to the fourth. I put it in parentheses because it's being raised to a power. It's important that you do that. Minus negative x squared. Again, put it in parentheses. Now, what do you know about anything that's negative raised to an even power? The answer is always positive. So negative x to the fourth becomes x to the fourth, and you can drop the parentheses. Minus, again, an even power, so that makes this negative x, just a positive x squared. Does this match that one? Absolutely. Okay. So since they match, that means our function is even. Okay. If we were checking odd, we don't have to check odd, just so you know, because we are even. You can't be both even and odd. If we were checking odd, what you wanted to do is you want to plug in a negative y and a negative x into our function. Remember, f of x is just a fancy way of saying y equals. Plug that in and see if we get out the original function. So if I plug in, well, this guy right here is negative y equal to this guy over here. We plug in those negative x's, just like what we did before. Okay? You already know what happens on this side. It becomes this. So, continuing on to another sheet. Again, we're on number 9. And it's coming from 3.3. So, we already know that this side right here turns into this. Now we want this y to be positive. So how do I get rid of a -1? Just divide everybody by a -1. And all really dividing by a -1 does is flip the signs. So that becomes 2x to the fourth plus x squared. So does this match the original equation? Positive 2x to the fourth plus x squared, does that match this one? And no, it doesn't. So that's why it's not odd. And we already proved that it was even earlier anyway. And the reason why we put in the negative x and the negative y, this one was symmetric with the y-axis. This one is symmetric with the with the origin. Okay, that's why you plug in the negative y and the negative x. To be odd, you're symmetric with the origin. To be even, you're symmetric with the y-axis. Okay? So again, our answer is even. So when we come into this, we're going to select A. To be a neither, just so you know, that means that you're neither even or odd. Okay? So if you are not even, you're not odd, you're in neither case. All right, number 10. So number 10, this one is coming from chapter 4 when we talked about linear functions, and it's coming from 4.4. 4.4. And we're talking about maximizing, okay?
Okay.
So maximizing means that they want you to find the vertex. All right. And this is a problem just like what we did in 4.4. So it says the manufacturer of a CD player has found that the revenue in dollars is R of P equals negative 4P squared plus 1,640P when the unit price is P dollars. If the manufacturer sets the price P to maximize revenue, what is the maximum revenue to the nearest whole dollar? All right. So again, to maximize, you want to find the vertex. Anytime you see that word maximize, it means find the vertex. So in order to find the vertex of this, what's the first thing we need to find? How do we find the vertex to this equation? I know you're back, Lorraine. I heard you.
Is it in? It could be over 2A. Really?
Yeah. Opposite of B over 2A.
Mm-hmm.
Remember, that's that x equals. This is what I call the AOS, the axis of symmetry.
Right.
So we got to find that. So here's our B. So we're going to put in the opposite of 1,640 all over 2. Here's our A, which is negative 4. So we're going to have negative 1,640 divided by a negative 8. So if you divide that, what is that? 205? Yeah, 205. And I know that I'm using X. I should probably just call this P. This is what P is. It's the price.
Okay.
Okay. So the price is 205. So if I want to find the maximum revenue, what am I going to do with this value of 205?
Plug it in for the price for P.
Just plug it in. That's right. So if I want to find the revenue, all I got to do, plug it in. So negative 4, 205 squared plus 1,640, 205. I'm just going to let my calculator do all the hard work. I'm going to put it in exactly the way I see it. Okay, just putting that into my calculator. And what do we end up for the maximum revenue?
You tell me. I'm still writing.
Okay, 168,100. And these are the answers that they're looking for. The price is 205. Maximum revenue is 168,100.
Okay.
So our answer up here is D. 168,100. Actually, they didn't want to know the price. They just wanted to know the max revenue. So we didn't have to look for the 205.
Oh.
But that would be the largest price.
Let's see.
All right. Number 11. And again, this one is coming from 4.4 as well.
Okay.
Okay. So it says you have 140 feet of fencing to enclose a rectangular region. What is the maximum area? So again, I see maximum. They're asking about the vertex.
Mm-hmm.
Okay. So first things first, we want to enclose a rectangular region. So I've got this rectangle and I want to enclose it. What does enclose mean in a mathematical term?
Area?
Not area. If I want to enclose this.
Perimeter.
Perimeter. So they're telling
Perimeter.
you
Perimeter.
the perimeter of this has to be 140 feet because that's how much fencing you have. Okay. In order to maximize area, well, what is the area formula for a rectangle?
Mm. It is. Where is it? I don't know. Oh, area equals length times width.
Length times width. All right. So we need to know the length and the width of this. And then once we know the length and the width of this, we can plug it in and figure out what we need. All right. So I want you to think about this with me. I'm going to let the length be called X because I don't know what X is. I mean, I don't know the length, right?
Okay.
So if this is X, how much is that side? This length is X. How much is this? It's a rectangle.
Sorry, going out again.
It's okay. So this side is X. The side across from it also has to be X. Now, how am I going to figure out the width? Well, let's think about this. If this is the width right here, this side is also the same width.
Right.
There's a formula for perimeter that says P equals 2L plus 2W. Let's do some plugging in and solve for the width, which we'll now figure out up here.
Okay.
Okay. So if I get W by itself, well, actually, let's do some plug in. Sorry. We need to plug into this formula first. What's the P got to be?
140.
140 equal to 2. What's L?
I want L.
Mm-hmm.
L
L is going to be X
mm-hmm.
plus 2W because we're trying to figure out what the width is.
Okay.
I mean, we already know what the length is. It's going to be X. We need to know what W is. So let's get W by itself. So how do I get rid of a positive 2X?
Minus 2x.
Okay. So that gives us 140 minus 2X equal to 2W. Now, how do I get this W by itself?
Okay.
Divide by 2.
Divide.
And I'm going to divide each one of these numbers by 2. So now we know that W is equal to, well, 140 divided by 2 is
70.
70. Minus 2 divided by 2 is just 1. So
X.
that's the width. 70 minus X.
Okay.
So now that we know the width, and we let L be the X, we can plug in over here. And we can maximize. So L is X, parenthesis, your W is 70 minus X.
Hold on. 1 second. I'm a little lost for a moment.
Do you know where the width came from?
Yeah.
All I did was take what I knew for W
Okay.
and what I knew for L, and I plugged it into my equation that you told me earlier.
Yeah.
Area is equal length times width. Here's my length. Here's my width. So now we need to distribute through. So x times 70 is 70x. Minus x times x, x squared. Now we can find the max area. All we have to do is run what we just did on number 10.
Yeah.
Okay, so the hard part about number 11 is you've got to generate the equation first. That's the tough part. Okay, and there's not a lot of information they provide you. You got to rely a little bit on some of that geometry skills that you know about. All right, so now that we have our equation, we can find the area. So, or we can actually find the max area, I should say. All right, so our equation is A equal to 70x minus x squared. Okay, that was the equation we had there. I'm just continuing this onto another piece of paper. All right, so the first thing we're gonna do is find the AOS, not the AOA.
Negative b over 2a.
There we go. AOS. X equals the opposite of b over 2a. Good. So our b value is actually right there because b is always in front of x, not x squared.
Right.
So we've got negative 70 all over 2 times our a value is right here. And so that's negative 1.
Negative 1.
So negative 70 divided by a negative 2 gives us
Negative 2.
Negative or positive 35.
Okay.
Okay. Now remember, that's what x was, which if you remember from our problem a second ago, x really represented the length of the rectangle. So we now know that the length is equal to 35 feet. Well, we need to find the width now. Well, remember we had an equation for the width. Okay. It was 70 minus x. That's our width. So the width is equal to 70 minus x, or in other words, 70 minus 35, which is also 35 feet. Now that you know the width, now that you know the length, we can find the area, which is 35 times 35. So the max area is 1,225 feet squared.
How much was it?
1,225 feet squared.
Okay.
And that answer will be C.
Feet.
Mhm. All right.
Can we just go over the basic steps real quick one more time?
The basic steps. The first thing you have to do
And we found the area.
is find your area
The
equation.
width. Okay.
Well, I mean, I guess the first thing you need to do is find your width. Let L
Yeah.
be X. Use the perimeter to help you find the width. The second
Okay.
piece you will do is find your area equation.
Mm-hmm.
And then the third part you will do is you will find the actual area. So you use that AOS to help you with finding the length. And then we had that width formula that we came up with, that width equation, and then length times width gives you the max area.
Okay.
All right.
All right. That's good.
Number 12. No worries. All right, number 12. Getting out of that stuff. So this is where we jumped into chapter 5, and this is coming from 5.1. Okay.
Okay.
So it says, is the function a polynomial? If it is, give its degree. If it's not, tell why. So we've got this function, f of x equal to x to the 3/2 minus x to the 5th plus 5. So the question is that a function? Well, what does it take to be a function?
I forgot.
Well, first off, all of the powers must have no variables. Any of my powers here have a variable?
All right.
Okay. Also, we
No.
cannot have, no. None of these
No.
powers have any variables. All right. The other thing is we can't have any variables in a denominator. Do we have any denominators?
No.
No. And all my powers need to be positive integers. Are all of these powers positive integers?
Yes.
No.
Oh, wait.
This is
Oh.
not an integer.
Right.
Okay. That's a rational number. So that is not an integer. So is this a function?
Nope.
No, not a function. And the reason being, because you have that fraction power. So let's go take a look at, so, I mean, really, there's only one answer. There's only one that says no, because x is raised to a non-integer power. That's what I was just talking about. That's not an integer, okay? A positive integer, like positive integers are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, no decimals, no fractions. So the answer has to be A. All right, number 13. Hey, we've already talked about this. And again, this is coming straight from section, we're dealing with rationals. So this is coming from section 5.3, although we've already talked about this earlier. So we want to find the domain of the rational. What do? How do we find domains of rationals?
We take the denominator,
Uh-huh.
equal it to 0.
You got it. So we're going to take this function that is x plus 5 all over x squared plus 4. And we're going to set that denominator of x squared plus 4 equal to 0. And it looks like they want set notation. All right, easy enough. So what do we do now with this?
Subtract 4 to both sides.
We can do that, definitely. So x squared is equal to -4. Now what?
Square root, both sides.
Square root. It is a plus, right? That was a plus. Just want to double check something. Yeah, okay. So we get x equal to
Plus or minus.
okay, plus or minus. I like the plus or minus idea.
-4. Square root.
Okay. Square root of negative 4.
Mm,
And what is
I
that?
keep losing you again. Sorry. Mm-hmm.
It's all right. What's the square root of negative 4?
2. -2.
Nope. Nope.
You can't have it, right?
That's right. You go to your calculator, you put the square root of negative 4.
Yeah.
Calculator says, I don't like it. And really, if you think about this, if you remember back from intermediate algebra, we can take the square root of this. Just remember it introduces complex numbers. So it really is 2i because the negative pops out, becomes I,
Right.
and square root of 4 is 2. But because this is complex,
Right.
is there any number up here that we do not like then? Any real values that we will not like? Any values that we have to throw out?
Mm.
No. And because this is complex, that means we're not throwing out any numbers. If this was a real number, like just say it was 2, then we'd be throwing out a positive 2 and a negative 2.
Okay.
But because this is complex, that means this domain is all reals. There is nothing we
Okay.
do not like. But again, like I said, if this was just plus or minus 2, then it would be x not equal to negative 2 and x not equal to a positive 2, because those numbers would be trouble. So if we go back, the only answer
Okay.
for us is D.
Because there's no numbers we don't like.
That's right. There are no numbers we don't like. So again, this would be like if B, this option B right here, would be like what would happen if it was a positive and a negative 2. That would be our answer if it was not complex and it was just plus or minus 2.
Okay.
All right. Number 14. We're getting there.
Okay. Okay.
14 is coming straight from 5.3 as well. And this is where we're talking about vertical asymptotes. How do we find a vertical asymptote of a rational? What do we do?
Vertical asymptote. Sorry. Rational. Okay. You know what? I forgot. My brain's not there.
It's okay. It's a lot like what we just did with the domain. You're going to take that denominator and you're going to set it equal to 0.
Okay.
You want to find the vertical asymptotes? That's what you have to do. Okay?
Okay.
So we're going to take this x squared plus 6x minus 72, and we're going to set it equal to 0. X squared plus 6x minus 72 equal to 0. What are we going to do now?
Factor it.
That's right. So this thing factors with x, one's going to be positive, one's going to be negative. Off the top of my head, I am not for certain on this one. Nope, it's not that one.
Yeah.
Nope. That's what I thought. All right. So it'll be a positive 12 and a
Okay.
negative 6.
Okay.
And then what do we do with these parentheses?
Equal them both to 0.
Equal them both to 0. So x plus 12 equals 0. X minus 6 equals 0. So we find out that our vertical asymptotes are x equals
-12, comma 6.
And x equals negative 6. These are two separate equations. They are equations.
Oh, yeah, you have to write them out. X.
That's right. X equals. So that's our answer. So when we come down here, Answer is D. Make sure you watch out for those signs because I almost said B, but the signs were opposite. So,
Gotcha.
oops. I think on my notes I put a -6. That should have been x equals a +6. There we go.
What section was that again? 5?
That was coming from section 5.3.
8.3. Okay.
Number 15 is also coming from section 5.3, as well as number 16 down here. Anything that has those asymptotes, we learned about that stuff in 5.3.
Okay.
All right. So number 15 says, give the equation of the horizontal asymptote. So when we do this guy,
Give equation.
how do we find the horizontal asymptotes?
Do you do something with the top?
Yeah, this is going to involve the top. What do we need to look at?
We need to, yeah.
What do we need to look at when we talk about horizontal and oblique? Both of these go together.
Oh, that's right.
What do we look at?
I'm trying to remember.
It's something to do with the numerator and the denominator.
Oh yeah. You have to, don't you divide them?
Nope.
No.
You need to look at the degree.
Degree. No.
Because there are four
Numerator,
cases.
degree, and general.
There are four
Right.
cases that you could have here. All right. So what is the numerator degree? What's the highest power? 3. What is the denominator
3.
degree? There's a 1 there. So it's 1.
1. Okay.
So the numerator is bigger than the denominator. What case is that? Where the numerator is bigger than the denominator.
Numerator bigger than the denominator. I mean, it's 1.
Say it again.
Is it 1? So why is 1?
Case 1? Nope. Case 1 is where the numerator is less than the denominator.
Right. So, so it's case 2. So you got to look at the leading
It's not
coefficient.
case 2. Case 2 is when
Right.
they are equal.
Oh. Oh, it's an oblique.
It is not oblique. That's case 3, where the numerator is bigger than the denominator by 1. Case 3 is where your numerator degree is bigger than the denominator by 1. This numerator is bigger than the denominator by 2. This is a case 4. Thank you for taking us through those cases, Lorraine. This is a case 4. So, case 4 means that there is no horizontal and actually no oblique. Case 4. Case 4 is when the numerator degree is bigger than the denominator degree by 2 or more. So
All right,
again,
I'll make sure to have those notes in front of me.
yeah. 16, and I didn't hear about having notes.
I was guessing.
All right, number 16. So, the answer to that one again.
Well, you know.
There is no horizontal, no oblique.
6.
So that answer would be D.
That's, yeah.
16 is going to be just like what we did. We got to look at those degrees again. It's just a different function. So f of x, and we want to know about the oblique. F of x equals x squared plus 2x minus 6 all over x minus 5. So again, we want to look at that numerator degree. and we want to look at the denominator degree. So what is the degree of the numerator?
2.
You got it. What is the degree of the denominator?
1.
1, because there's a 1 there. So this is case 3, as we mentioned earlier, which means we do have
Okay.
an oblique asymptote. Because in case 3, it means the numerator degree is bigger than the denominator degree by 1. 2 is bigger than 1 by 1. So in order to deal with this, you're going to do long division to find the answer. And this answer should look like a linear equation. Y equals mx plus b. So we're going to take x squared plus 2x minus 6. All right. So let's do long division. What times x will give me x squared?
Another x.
All right. So we're going to take this x and we're going to multiply it through there. X times the x minus 5. So x times x is x squared. That's not a shocker. X times negative 5 is negative 5x. And then what do we do going down now?
Subtract down.
Subtract down. And I always write this out to make sure I do the correct subtraction. So I have 2x minus negative 5x. So actually, I'm not really subtracting down. I'm really just going to be adding. What's 2x plus 5x?
7x.
7x. And then the negative 6 trickles on down. Now, you just repeat the process, but we don't actually have to finish it. We want to know what times x will give me 7x.
Right. 7.
That's right. What times x gives me 7x? So that would be a positive 7, and that's where you stop. We don't care about the remainder. We just want these first two pieces. So our answer is, as an oblique asymptote, y equals x plus 7. See, y equals, there's an m here of 1, x plus b. So that right there is our answer. Now we just got to go find it. And right here, a, y equals x plus 7. There we go. Any questions about number 16?
No, that was 5.3. Okay.
That was 5.3. All right,
Okay.
we're getting there. Number 17 is coming from 5.4. All it wants to know is, what are the x-intercepts of this? How do we find the x-intercepts of a rational? This is coming from 5.4. How
Do
find
we need to factor the bottom or factor it if it can be factored first, right?
that bottom is not going to be factorable.
Oh yeah, because of the negative.
But that would be a good idea, but it's even easier than that.
Oh.
So how do we find the x-intercepts for this? What do we do?
Equal to 0?
Who to 0?
Oh, the denominator.
Nope.
Oh, the numerator. Sorry.
The numerator. Set the numerator equal to 0, and that will tell you the x-intercepts. So x is equal to a positive 9, and they want this written as a point. Remember, x-intercepts as a point look like
Okay.
the number, comma, 0. So our answer is 9, 0. Just set the numerator equal to 0.
9.
So out here,
Okay.
B is the answer. Okay. Feeling okay there, Lorraine?
Yes.
All right. 18. This one is coming from 5.5.
All right.
All right, 5.5. So we want to know the answers to this.
Solve inequality. Being
So remember that I told you the first thing when dealing with inequalities, especially when it comes as a polynomial, because that's what this one is, you need to find those critical values. And what are the critical values we're going to be looking at? Who do we need to find for polynomials? What were those critical values we cared about?
X.
Well, it's B in this case.
Oh.
But what about X?
Well, yeah.
What we want to know what? X.
No, values.
Change the word values. X.
Sorry.
X.
Intervals?
Not intervals, but intercepts.
Oh, intercept.
That's the critical values we're looking for.
Right.
And cool thing is, this thing's already factored for us. All we have to do is take these parentheses and do what with them?
Multiply them?
No. We want to find x-intercepts. It's already factored. How do I find x-intercepts when we're factored? Set the parentheses. Say that again.
Oh. Yeah.
Just take each parenthesis, set it equal to 0.
Equal to 0?
Yeah.
You're cutting out.
Sorry.
Okay.
So take each parenthesis, set it equal to 0. I know it might be cutting out for you, but when the video is actually recording everything that I'm doing, so it'll be crystal clear on the other side. Sorry that it's cutting out on you though. So minus 2. I don't know why I just showed that. So one of our x-intercepts is -2. Add 4. One of our other x-intercepts is 4. Add 7. Another intercept is 7. Now remember that these are the critical values, and we use these critical values to create intervals. So we got -2, 4, and 7. So remember that this created intervals for us, where the interval below -2, this interval is -infinity to -2. The interval between here is -2 to 4. The interval between 4 and 7 is 4 to 7. And the interval above 7 is 7 to infinity. Okay? What we want to know about these intervals, these little ones right in here, is we want to know, do the numbers produce positive answers or negative answers? So we're going to select a number smaller than -3, and we're going to test it. Or sorry, I said -3. We're going to select a number smaller than -2 and test it. I'm going to test -3. We're going to select a number between -2 and 4. Easy enough number, 0. We're going to select a number between 4 and 7. I'm going to choose 5. And we're going to select a number above 7. I'm going to choose 8. And all I want to do is take these numbers. Oh, sorry, you can't see my intervals. So, based off of the critical values, we have 4 intervals. -infinity to -2, that's what this interval is all about. -2 to 4, that's what this interval is about. 4 to 7, and 7 and above. And again, we're picking values in each one of these intervals -3 is in this interval, 0 is in this interval, 5 is in this interval, 8 is in this interval, and all I want to know is if the answers, when I plug these numbers in, so I'm going to put a -3 in each one of these spots, all I want to know is if the answer is positive or negative. We're going to take 0 that we have down here, and we're going to plug it into each one of these B's and figure out if it's positive or negative. We're going to take the 5 and plug it in and figure out if it's positive or negative. And we're going to take the 8 and plug it in and figure out if it's positive or negative. I'm going to use my calculator to cheat on this. Here's how you can use your calculator to cheat. Go into the y equals and put in our equation because it's already ready to go. So we're going to have parenthesis x, I know it's b, but we got to use x because it's our calculator, plus 2, parenthesis x minus 4, parenthesis x minus 7. And then I'm just going to go straight into the table. So hit second graph. And now I can look at those answers that we wanted to know. One of them was, I wanted to plug in -3. So that answer was negative. So if you look right here, when we plug in -3, we knew that the answer was negative. So that means this interval is a negative interval. Okay? That's going to be important for us here in a second. So if I plug in 0, the number's positive. So that means the interval from -2 to 4 is a positive interval. If we plug in 5, notice it's negative. So the interval from 4 to 7 is negative. And then the last one, if we plug in 8, I'm going to have to scroll down, it is positive.
Mm-hmm. Okay.
So this is what we know. This interval is negative. This interval is positive. This interval is negative. This interval is positive.
Okay.
Here's where we're going to go up here. And I pretty much have ignored this piece until now. Now is when we look at this part.
Okay.
It says I want to be less than 0. If we are less than 0, what kind of answers do we want?
Oh yeah, that's on the pad. Yeah.
Negative?
You got it. So in order to answer our question, we need the negative intervals. And because this is less than, we will have parentheses. If it was less than or equal to, then we would have used brackets. But because it is less than, we'll use parentheses. So
Okay.
here's a negative interval. So part of our answer is -∞ to -2.
Okay.
Here's a negative interval. So this is also a part of our interval answer. 4 to 7. We don't worry about the other two because they were positive. We only wanted negative answers. So right there are our solutions.
I'm gonna take a picture of that.
So we need to come back, and our answer is C. Okay.
See.
Any questions about what we did on number 18?
No,
There's
just
kind of-
trying to print it
No worries.
with notes.
All right. So now we jump into chapter 6. Okay, so now we're in that last module. So from 19 on through the end, I believe this should all be chapter 6. So number 19 wants us to do composition. It wants us to do what I call fog, F of G. So that means we're going to take the G function and we're going to plug it in, the G function, we're going to plug it into the F function. So f of x is equal to 5x plus
I think so,
13.
yeah.
G of x is
Yeah,
equal
can
to
you hear me?
2x
Oh,
minus
there you are.
1.
Sorry, I was on mute, sorry.
And again, as I said, it wants us to run
Yep, already did, yep.
fog. Or another way to write this is f of
No, you're fine.
g of x like that. Take the g function, plug it into f. So f of g is going to equal 5. Oh, I see x. That's where g goes. 2x minus 1. And then plus 13.
Okay.
So this is taking g and plugging it into x,
Yeah,
because
I'm
this
good.
used to be x. All we do now is just, some cleanup. We're going to distribute the 5 through, which gives us 10x minus 5 plus
Okay,
13.
that's what- Okay.
Combine like terms. 10x plus 8. And that's what they want. So if we go back and take a look, that is B.
You think they'll give us the fog one? In the test?
Anything's possible.
Okay.
All right, down here on number 20. Oh, I didn't tell you guys where this one was coming from. This is all 6.1.
6-1, yeah.
6.1. Same thing for number 20 is 6.1. So in 6.1, they want us to take this apart. Okay. So here's the end function, and they want us to undo it. Here's how I would approach this. I would look at these answers, and it's composed of fog, which means that we need to plug G into F. I would take each one of these answers and see if when I take G and plug it into F,
Yeah.
do I get the H of X? That's what I would check. So if I'm looking at answer A,
Mm-hmm.
my F of X is equal to 1 over X.
Yes.
My G of X is equal to X squared minus 3. Again, we're looking at
Okay.
fog. Okay? So if we run fog on this, if I take my G and plug it into F of X,
Now, the only thing is
we
that
get this
I probably
answer,
have to upgrade my
1
because
over
I have
X squared
correct ton of
minus
stuff.
3.
Like, all my kids are all over the
So
place.
is
Everything
this
runs on our internet.
the same as that H?
So, probably.
Yep, it matches 100%. So the answer has to be A. If you check the other ones, they do not work. Okay? And I'll show you those real quick. So this is choice B. This is what it looks like when you run fog.
You know what the unlimited data?
It is,
Well, right now I'm paying 109, so $40.
sorry, I'm just going to go ahead and work up these answers real quick so you can see what they look like. This is what fog would look like for this guy.
Over.
Oh, there is, okay.
And D, fog would look like this.
Okay, and see what they say, see what it all means. Okay. Okay. Oh, okay, I'll call that. Yeah. See what this all means?
So these are what the other answers look like if we played fog to them.
Yeah, okay, sounds good. I'll call them. Awesome.
This does
Thank
not
you.
look like that.
All right. Have a good day.
This does not look like that. This one does not look like that one. So you see how you just use their answers, apply the fog, and see which one matched the H of X. Does that make sense? Okay.
Yeah.
Number 21. Okay. Number 21. This one is coming from section 6.2. Okay. It says the graph of a one-to-one function is given. Since it's one-to-one, that means we can find the inverse. Okay. It wants us to draw the graph of the inverse as a dashed line or a curve. Okay. So let's talk about how do we find the inverse of this, and we can use our calculator to help us figure out which one of these pictures it should be. Okay. All right. So the way we find inverse is you're going to switch the x and y values. Remember, f of x is just a fancy way of saying y. So all we're going to do is we're going to switch these two variables. So x is equal to y to the third plus 1. And now all you're going to do is solve for y. So let's get y by itself. How do I get rid of plus 1? Subtract 1. That gives us x minus 1 equals to y to the third. How do you get rid of something cubed? Cube root it. So y is equal to the cube root of x minus 1. Or if using the inverse notation, it would look like this. F of negative 1 of x, or in other words, f inverse is equal to the cube root of x minus 1. So just go to your calculator and plug that in. So we come right over in here. Your cube root is under math, and it's right there at number 4. Hey, look, that looks just like what I wrote on my paper. X minus 1. Hit graph. There's the inverse, and there was only one picture that looked just like that. And you can also put in the previous equation, which was x cubed plus 1. And if you hit graph, this is the picture, this is the graph that we're looking for. So if we go back, we only had 2 choices, 50-50 shot. The one that looks like that picture is B. Use your calculator. All right.
My internet's out.
It's okay.
I can't even see you.
Sorry. Number 22. So we're going to solve this equation. This is where we are in 6.3. So you got 32 to the x minus 1 equal to 16 to the 3x. Remember, when solving exponentials, you can use logs to help, but sometimes it helps with when solving exponentials to remember that if your bases are the same number, then we can just set the powers equal to each other. So, and we can show that. 32 is actually made up of 2. 32 is 2 to the 4th power. That's what that 32 is. It's 2 to the 4th. 16 is really 2 to the 3rd. Okay? Well, what do we do with powers in parentheses? You can multiply those through. So we get 2. 4 times x is 4x. And 4 times negative 1 is negative 4. Equal to 3 times 3x is 9x. Since these bases are the same, that means the powers have to be same. So that means all we got to do is set them equal to each other, and we can solve. Because the bases are the same, the powers have to be the same. So minus 4x minus 4x, negative 4 is equal to 5x. divide by 5, divide by 5. We now know that x is equal to negative 4/5. So all we have to do then is go and look to see where that answer is. And it is not on there.
What?
So let me just double check something real quick. I messed up. My bad. I knew something was weird. Let's go back and fix my math. I had a Mr. Armstrong moment. 2 to the 4th is not 32. 2 to the 4th is actually the 16. So this should have been 2 to the 4th, which makes that 12. This should have been 2 to the 5th, which makes these guys 5. Now that I'm fixing my mistake, let's go back through and fix this. Sorry about that, but it's an easy fix, honest mistake. Operations and all that are still going to stay the same. Just had to change my numbers. My bad.
New customer.
So this is 5x minus 5. And this will be 12x.
No.
So we're subtracting 5, subtracting 5. 12 minus 5 gives us
Oh.
8. Make sure of that again. No, 12 minus 5 is not 8. I'm making those stupid mistakes again. Is 7. Divide by 7. And our real answer is negative 5/7. That was my fault. But it's still the same principle. 2 to the 5th is 32. 2 to the 4th is 16. Distribute the 5 through. And because the bases are the same, and take the 4 times the 3x, because the bases are the same, we can set the powers equal to each other. So now if we go and look, right there, it's D. There we go. All right. So that's number 22 from 6.3. Number 23. This one is officially coming from 6.4. Okay. And they want us, again, to solve the logarithm. So log base 42, x squared minus x equal to 1. One of the ways that you learn how to solve logs is to remember that it is actually the inverse of an exponent. So we could actually take this log that we have here and we can turn it back into exponents. Because if you remember, log base A of B equal to C really does look like A to the C equal to B. So this is if you want to reverse back and forth between these two. So that means that this piece right here looks like 42 to the first equal to x squared minus x. Now that's something that we can solve. 42 to the first is just 42.
Sorry.
It's okay. And all we got to do is set this equal to 0 so that we can factor. Move the 42.
And I'm trying to sign up for equipment, and I'm not sure what.
So that gives us x squared minus x minus 42 equal to 0. So all we have to do is factor that. And this will factor to
So for the equipment,
x with a plus and x with a minus. Double checking. Yep. So this will be a positive 6, a negative 7. Set these equal to 0. X plus 6 equals 0. X minus 7 equal to 0. We now know that x is equal to a negative 6 x is equal to a positive 7.
Okay.
Okay?
Mhm. Okay.
So we go back and we check our answers. And our answers are going to be number,
And then
or not
I
number,
guess, do
letter
I
B.
need,
There's the negative
if
6
I don't have
and
any
the
X,
7.
I would be a new customer. So do I need the digital adapter?
So answer's B.
Okay.
All right.
And I assume I will-
24, we want to solve the ln. Okay.
Yeah, I do.
So
We do. That's what I'm working on. They have
this
a
is
report
coming
to fill out, so that's why I was
from
like, I don't understand any of this.
section 6.6.
Okay.
A lot of these, when we got to the log sections, a lot of them had a lot of like bleed over into each
I have
other.
it. That's what I'm
But
doing right now.
This
So-
one's coming from 6.6. So
And then my other
is
question is about internet.
number
So
25
it
also
says
coming
I
from
can do, like,
6.6.
retrieve,
So lots of different things right there.
150,
All right.
MB, but I have
So we
a lot
got
more equipment.
5
So I work from
plus
home, I have kids.
4
So is there something that's more,
ln x
like,
equal
more than
to
that? Like there's an
12.
unlimited data usage. What is?
All right. So the first thing you're going to do in this
Mm-hmm.
is we need to get the ln by itself. So how do I get rid of a positive 5? Subtract 5.
Okay.
So that would be 4 ln of x equal to 7. How do I get rid of multiplication here?
Division.
Divide by
Right,
4,
right.
divide by 4.
Okay.
So ln of x is equal to 7/4.
Okay.
So again, just like what we talked about earlier, we can turn this back into its exponent, or another way to get rid of ln
Yeah.
is to raise both sides
Okay.
to an e.
Yeah, because I don't mind even paying for it.
So in other words, what this will look like,
Running right now, so I want to make sure that it, we can like keep everything.
if I raise that ln of
Now,
x
do I need to get additional equipment
to the
for
e,
that?
it looks like this. It's like I'm putting an e below it. These are now my powers. What does
Okay.
e and ln do? They cancel each other out, leaving you with
They'll-
x.
Okay.
And then over here,
All right. Okay.
that is the
You
answer.
answered my questions then. Perfect. Thank you so much.
e to the
No,
7/4.
that's it. Thank you.
Because the
Okay,
e and the ln
Thank-
undo
okay.
each other, leaving you with x.
Okay. Undo each other.
They're the inverses of each other. So if we're looking at this, the answer is D.
Okay.
Right.
Not bad.
Number 25.
Okay.
Again, another 6.6. We got this e to the x plus 8 equal to 4. All right. So this is an exponent. It's going to be kind of like just like what we did in number 24. Okay. The exponent is by itself. How do I get rid of the e?
ln.
Well, we're going to take an ln of both sides. Okay. Just like before, how did I get rid of ln? I raised it to the e, or I made a base of an e. So we're going to ln both sides. So the ln and the e cancel each other out, leaving us with x plus 8 equal to, and over here, that is now ln of 4. Now, how do I get the x by itself? Subtract 8. Subtract 8. Do not take 4 minus 8. That is incorrect.
Mm-mm.
So what we have is
ln.
negative 8 plus ln of 4. Or another way that you can write this would be ln of 4, and technically this should be in parentheses, minus 8. Okay? Both of those are correct.
Okay.
And if we go back in there and look for our answer, there it is. ln of 4 minus 8. It really should be in parentheses right there, because to me, this looks like I need to subtract the 4 and the 8. So this is actually the answer. D.
D.
All right.
Moving along.
Number 26. This is going to seem like it jumps back. Number 26 and number 27, we are jumping back into 6.5 with properties of logarithms. This is where we're going to condense and expand. That's what these two questions are. So this is coming from 6.5. So what they want us to do in this one is they want you to expand the logarithm out. All right. So we've got log base 13 of the 7th root of 4 divided by s squared r. Okay. So let's start talking about this. First off, this radical, we need to turn this into an exponent. The 7th root, what does that look like as an exponent? It's 4 to what power?
Second.
What is the 7th root of 4? What does this 7th root look like as an exponent, a power on the 4? Like, I'll give you a hint. A square root is 1/2. A cube root is 1/3.
Yeah.
What's a 7th root?
Oh, 3.5.
1/7.
1/7.
Okay. All right. Now that we have that, we can start working on expanding. What does division mean? With logarithms, when I expand out, what operation is division?
Multiplication?
Nope.
No, subtraction.
Subtraction.
Yeah.
So we're going to go ahead and take care of the division first, and we're going to expand out to log base 13, not 12.
Take care of division first. Y subtraction.
4 to the 1/7 minus log base 13 s squared r. So the division turned into subtraction.
Okay.
Okay.
Mm-hmm.
Now, if you look right here, what's going on between these two?
Multiplication. So you add them.
All right. So we're going to expand out even further. We're going to keep the long base 13 of 4/7. And we're going to need to put parentheses now because we're expanding all this out even more. And all this is to be subtracted by that. So you need that parenthesis there. Log base 13 s squared plus log base 13 r, because the multiplication between those two becomes addition. Close the parenthesis. So we took care of division, which became subtraction. We took care of multiplication, which became addition. Now, the only other thing is, what do we do with the powers up here in expanding out? What are we going to do with these powers?
Combine them or no?
Nope. Where do they move? Where's this power going to go?
I don't know.
It's going to shift to the front.
Oh,
So you have 1/7 log base 13, 4, minus, oh, there's a power, so that's going to shift to the front, 2 log base 13, of S plus log base 13 R.
Close.
This is technically a good answer. What they will do on us, because we have parentheses and because you have this minus here, it will actually distribute that minus through.
Okay.
And the final answer that they will give you looks like this. 1/7 log base 13 of 4 minus 2 log base 13 of S minus log base 13 of R. That's the final answer. All they did was just take the negative and distribute it through. But technically, both of these are correct. Both of them are fully expanded out. So when we come back and we look, which one is the one that we're looking at? And there it is. It is C. Because there's the 1/7 log base 13 of 4 minus 2 log base 13 of S minus log base 13 of R.
Oh, distribute negative.
And
Okay.
it looks like B is also an answer because it looks like it is the exact same answer. There should be only one, just so you know. Yeah. Oh, wait, no.
No.
Nope, it's got an extra 2 there. Never mind. Nope. It's just C.
See.
Watch out for those subtle differences. There's a 2 here, and it shouldn't have a 2. All right.
Okay.
So number 27, all we're going to do is take it backwards. We just expanded. Now we're going to reverse it. So again, this is coming from 6.5. So log base. Oh, sorry. We're actually going to solve. Never mind. I thought we were condensing back down again. So again, this is coming back from this is coming back from 6.6, where we are solving logs. But we are going to use some of that information that we did just talk about, though. We are going to have to do a little bit of condensing down to help us out. But this is coming from 6.6.
Okay.
Okay. So now, let's take a look at this and let's solve. Remember how I said that we do need to use a little bit of what we talked about? So we learned how to expand back out. We also need to know that it can work the other way. We condense back down.
Mm-hmm.
This minus right here between these two logs, what does that really represent for us?
Division.
So we can put these logs back together and make it look like this. The minus really looks like division between these two. And just like what we talked about earlier, when your exponents have the same base, we can put the powers equal to each other. Notice these are the same logs. So that means we can set the pieces after the logs equal to each other. Whenever the logs are the same, you can set their pieces equal to each other. So this is equal to that. Now all we have to do is solve.
So 3 plus x.
So what number is this 4 over?
1.
This is just a proportion. How do we solve proportions?
Cross multiply.
So we're going to take 3 plus x times 1, which gives us 3 plus x. And we're going to take x minus 4 times 4, which will give us 4x minus 16, because the 4 has to multiply all of that. And then now we just continue solving. Minus 4x minus 4x. So we get 3 minus 3x equal to negative 16. And then we're going to subtract 3. Subtract 3. Negative 3x is equal to, this gives us negative 19. Divide by negative 3. Divide by negative 3. And x is equal to 19 over 3.
Okay.
And when we go back and look, 19 over 3 looks like they did the division. 19 over 3 should be 6.3333, repeating. 19 divided by 3. Yes. So that answer is C.
Let's see further. When in doubt, pick C.
No.
I'm kidding.
All right. So 28 and 29 are coming from 6.8. 28 and 29 are coming from 6.8. Number 30, it's going to jump back, and number 30 is going to come from 6.5. Okay? But number 30 will just be a calculator use. All right, but number 28 and 29 are 6.8. Number 30, 6.5. All right, and that will wrap up the exam. So number 28. So it says the value of a particular investment follows a pattern of exponential growth. In the year 2000, you invest money in a money market account. The value of your interest T years after 2000 is given by the exponential growth model. A equals 6,900 e to the 0.062 t. By what percentage is the account increasing? So we've got this formula, this equation.
Mhm.
Okay. And they want to know what is the percent increase. That means they're looking for the growth rate. So, who in here tells us the growth rate?
With the 0.062?
You got it. The growth rate or decay rate is right here located by your T. So 0.062. But again, when we're working with math and we're plugging into equations, we can't plug percents into the equation. This is the decimal version
Right.
of that percent. So what is the real percent?
6.2.
6.2%. Because you're going to take and move that decimal 2 places to the right. That is what number 28 is about. And so that gives us again, the answer is not there, and it should be 6.2.
Yeah, they must have did something wrong. They put a number wrong.
That's all right. So good question. Well, we know what the answer is. It's just not given.
There's not an option for that one.
Not an option. Well, we'll fix that at a later date, Deanna. All right. Strontium 90 decays at a constant rate of 2.44% per year. Therefore, the equation of the amount P of strontium 90 after T years is P equals P sub 0 e to the negative 0.0244 T. How long will it take for 15 grams of strontium to decay to 5 grams? Round answer to 2 decimal places. Okay. So you know T is in years. So we've got this equation that I'm writing down on my piece of paper right now.
Mhm.
All right. They have told us these two values. We're going to be looking for T. So it says, how long will it take 15 grams? So that is our P of 0, because this first number in front of E is your initial amount. Like up here, your initial amount was $6,900 that we put into the money market account.
Okay.
So down here, this P of 0, that's our initial amount. That P value, that's what we have in the end, the ending amount. So they told us in the end, we have 5 grams. So we're going to take that 5 and we're going to put it in for P. We're going to take the 15, put it in for P sub 0. And this is what our equation now looks like. Right here.
Okay, hold on. 5 equals 15E. Okay.
So all we have to do is get the T by itself. So we're going to divide by 15. That gives us 1/3, because you do want to reduce that. E to the negative 0.0244 T. How do I get an exponent of E? How do I get rid of that?
ln.
ln both sides. So that gives us ln of 1/3 equal to the ln and the E cancel each other out. Negative 0.0244 T.
Now you divide.
Divide. There's the last step. Negative 0.0244. Divide by negative 0.0244. So we need to go to our calculator and we need to let it do the division of this. So, calculator. Hope we can clear all this out. Second quit. Notice you haven't had to use your calculator very much in this.
Yeah.
Alpha y equals. Here's your ln button. Put alpha y equals again, because it's a 1/3. Scroll out to the side, close that. All over negative 0.0244. And we're going to round to 2 decimal places. So 2 decimal places, the 5 says, hey 2, go up. So we are 45.03 years. Because that 5 says, hey 2, go up. So when we go back, our answer is A. This is it, the last problem. And again, this is coming from 6 point, I think I said it was 5?
Yeah.
Yeah. So number 30, 6.5. All they want you to do is run the change of base formula.
Change your base formula.
Okay. And there are lots of ways to run the change of base formula. I'll show you that here in a second. But those of you that are using the TI-84, you don't have to run the change of base formula because the calculator will run it for you anyway. All you got to do is put in log 5.2177 in the calculator. It says round to 2 decimal places. So, well, I mean, if you're looking at this, if we're rounding to 2 decimal places, you already know what the answer is. It has to be B, because that's the only one that's rounded to 2 decimal places. But let's double check that 3.14 and make sure that our answer actually exists on here. So if I want to run a log that has a weird base, remember we're gonna hit math.
Oh.
And I believe we go over to number. Nope, it was under math. Under math, scroll up,
Oh.
and you want A, log base.
Oh. Now scroll up.
So we're going to put in the 5.2. And then you're going to scroll over and hit 177. Rounded to 2 decimal places. The 9 says, hey, 3 go up. So yes, I agree that it is 3.14, which was B. Now, let me show you the change of base formula real quick. Change of base formula, you have a couple different ways to do this. This is log A of B. When you run the change of base formula, you can do this one of 3 ways. You can, or I'm just going to show you 2. Don't worry about the 3rd way. You can do it with log base 10. So just log of, I believe it is the B over the A. I've forgotten for 1 second because normally I just run it in the calculator. So 6.5. I'm just looking up the equation real quick. Sorry about that. Change of base. There it is. Yes. So it's log of B over log of A. These are the numbers you use.
Oh.
Or it's the same thing as if you did it with ln. ln of B over ln of A. So you can go into your calculator and run log of 177 over log of 5.2, or run ln of 177 over ln of 5.2. Both of these are the change of base formula that lead you right back to that. Just to show you real quick. So alpha y equals log 177 over log 5.2. Same answer. Or do ln. ln, oops, sorry. Alpha y equals ln 177 over ln 5.2. Same answer. And that is your college algebra final, questions 1 through 30, spanning chapters pretty much 1 through 6. If it's not on this, it ain't on the final. Any questions?
Awesome. It was great.
Perfect.
Thank you.
I wish you all good luck. Have fun. Enjoy
Thank
your
you.
finals.
All right. Thank you.
Bye.
Bye-bye.